Hello everyone and welcome to the lecture on AWS Wavelength. What is AWS Wavelength? AWS Wavelength is designed to support applications that require extremely low latency for mobile devices and end users, making it ideal for use cases such as real-time gaming, augmented reality, and virtual reality. Wavelength allows developers to deploy applications that require low latency and a connection to AWS services in the region by extending AWS compute and storage services to the edge of telecommunications provider 5G networks. 3. Wavelength zones are AWS infrastructure deployments that embed AWS compute and storage services within telecommunications providers' data centers at the edge of their networks, bringing AWS services closer to end users. Wavelength is particularly useful for applications that require real-time processing such as autonomous vehicles, industrial automation, and real-time gaming, as it provides ultra-low latency and a connection to AWS services. AWS Wavelength enables low latency access to compute infrastructure for data processing and analytics, which is essential for applications like connected vehicles, media and entertainment, and augmented reality and virtual reality. AWS Wavelength is available in collaboration with various telecommunication providers such as Verizon, Vodafone, KDDI, and SK Telecom, and is being piloted in Verizon's 5G Edge in Chicago. So this is as per one of the blogs. But so to summarize, actually, Wavelength is AWS works along with telecom providers so that they can set up their infrastructure close to their data center or just next to them, so that for example, your mobile devices or gaming devices, as soon as they want to connect, they just come out of 5G network, and immediately they can reduce some network hops, and they can immediately go to, for example, let's say you have EC2 which is running on wavelength zone or wavelength, so it will not have to travel so much in the network, and as soon as the phone or device goes out of 5G network, immediately it will be landing, or it will be arriving at the AWS regions or AWS services. So this is basically AWS working alongside these telecom providers to provide low latency and faster network. So some AWS resources supported in Wavelength are EC2 instances, EBS volumes, VPC subnets, carrier gateways, and it also supports EC2 auto scaling, elastic Kubernetes service clusters, elastic container service clusters, systems manager, CloudWatch, CloudTrail, and CloudFormation. So as of this recording, these services can be operated in the Wavelength. So how AWS Wavelength works? So you have VPCs which are your outer boundary inside a region, and they connect. So VPCs that contain a subnet in a wavelength zone can connect to a carrier gateway. A carrier gateway allows you to connect to the following resources, which are 4G LTE or 5G devices on the telecommunication carrier network, and outbound traffic to public internet resources. So over here, so whole this VPC is extending into a wavelength zone, and it is next to a telecom provider's data center. Then you have subnets, any subnet that you create in a wavelength zone. So we are talking about this subnet over here at wavelength zone, inherits the main VPC route table, which includes the local route. The local route enables connectivity between the subnets in the VPC, including the subnets that are in the wavelength zone. So basically, because it's inheriting the route table at VPC level, so all these instances can communicate with each other freely. Next important component is carrier gateway. So a carrier gateway serves two purposes. It allows inbound traffic from a carrier network in a specific location, and it allows outbound traffic to the carrier network and the internet. There is no inbound connection configuration from the internet to a wavelength zone through the carrier gateway. A carrier gateway supports IPv4 traffic. Carrier gateways are only available for VPCs that contain subnets in a wavelength zone. The carrier gateway provides connectivity between your wavelength zone and the telecommunication carrier and devices on the telecommunication carrier network. The carrier gateway performs NAT, network address translation of the wavelength instances IP addresses to the carrier IP addresses from a pool that is assigned to the network border group. The carrier gateway NAT function is similar to how an internet gateway functions in a region. Okay, next thing is carrier IP addresses. A carrier IP address is the address that you assign to a network interface which resides in a subnet in a wavelength zone. For example, on an EC2 instance, the carrier gateway uses the address for traffic from the interface to the internet or to mobile devices. The carrier gateway uses NAT to translate the address and then sends the traffic to the destination. Traffic from the telecommunication carrier network routes through the carrier gateway. You allocate a carrier IP address from a network border group, which is a unique set of availability zones, local zones or wavelength zones from which AWS advertises these IP addresses. So it has a very specific in each availability zone and each wavelength zone. It has a very specific format, and from that network border group, it will publish or advertise those addresses for basically for outbound communication and communication from here inbound from the communication service provider network. Okay, last point is around routing. So you can set the carrier gateway as a destination in a route table for the following resources. One, VPCs that contain subnets in a wavelength zone and subnets in wavelength zones. So create custom route tables for the subnets in the wavelength zones so that the default route goes to the carrier gateway, which then sends traffic to the internet and the telecommunication carrier network. So I'll just show you this one. Okay, so herein I have put a route table. So route table can be existing here, and this will have an entry for this to connect outside the provider network, telecom provider network, or if it wants to fetch something from outside the internet, but you cannot initiate from here to here. So that's why this is both way communication between here to the telecom provider network, but from internet you cannot initiate, but you can actually initiate from here if you want to download or fetch some resource, and you can get back. And these devices, mobile tablets or other devices on the telecom provider network can connect through here. So that's what I was talking about, because this is exactly right next to here. So we are skipping a lot of network hops from let's say from 5G network directly it's coming over, because AWS is working alongside with telecom providers. So we are skipping those, and you can actually deploy something over here. Let's say you have a game which need ultra low latency, so you can and it needs some content, for example some server over here. So you can just come here, fetch that data and serve it to your tablets or mobiles. So these can be very big powerful instances, but they will be sitting next to the data center which is next to the telecom provider. So now last is architecting apps for wavelength zones. So this will be a bit of repetition, but I'll just cover it. So wavelength zones support applications which require minimal delay, optimizing experiences on 5G networks. And these zones ensure stable data rates from mobile devices to compute resources, which is crucial for the performance. It is aimed at parts of applications that need quick interaction. So it may not be whole application, but parts of applications in some cases, which can enhance efficiency and user satisfaction. AWS suggests designing edge apps with this model, using the region as a hub for scalability and resilience. Services in wavelength zones comply differently, so affecting how you want to manage data and applications. Access within zones is tailored to specific telecom carriers and locations, which necessitates multiple zones for comprehensive coverage. So it's not just because you have to work with different telecom providers. So you have to see which all is available. So maybe in some other region you have to work alongside some other telecom provider, and some other wavelength zone you have to enable. So depending on how your application is spread out, and to meet diverse latency requirements, you may be required to employ several wavelength zones, may be necessary. Okay, and that's all. Thanks for watching.